Hello everyone and welcome to our channel Design Station. The following video will be based on the sheet metal fixture for CNC machine. So the following equipment we are making is a sheet metal fixture, which is an equipment used for holding a material onto a particular position. This can be used in a CNC machine for the purpose of milling and drilling. The following project was conducted at the BITS Pilani Dubai campus, and the CNC machine used here is the Jyoti Milltap 10. The following project requires supervision from faculty members, so care must be taken while performing the project. So the first step for our project is to create a CAD model of the sheet metal fixture.
Start by clicking on the sketch option to create a new sketch and select the XZ plane. Before we create the sketch, go to the Tools tab and click on the Document Settings. Then click on the Units tab to change the length unit from inch to millimeters. Now click on the 2-point center rectangle option to create a rectangle of size 152 mm breadth by 167 mm length. Now create a line of length 29 mm to create a hole of radius 10 mm. It should be about 45 degrees from the edge of the rectangle. Use Circle option to create a 10 mm dia circle. Using Line option, create a reference horizontal line and vertical line at the center. Using the Mirror option, select the Mirror Line option to select the vertical line to create a copy exactly opposite to left. Now select the two circles and create a copy exactly below the horizontal line using the Mirror option. Use the point option and adjust it in such a way that it is 16.5 mm from the top and 57 mm from the right. Use the dimensions option to adjust the values as shown in video. You can easily edit the dimensions if error creep in. Use the mirror option to create a mirror of the point onto the left side. Use the mirror option again to create the same points on the bottom using horizontal line. Now go to the point option to create a new point that is 14 mm from the left and 49 mm from top. Now create a mirror of the point below the horizontal line, which can be done by using the horizontal reference line as the mirror line. Select the present 2 points to create a mirror of them on the right side using the vertical reference line as the mirror line. Now create a circle of diameter 16 mm and copy each of the circle to the points we have created. Use the center point of the circle as the base point and copy them to the new points. Now create a new rectangle sketch using the 2-point center option to create a rectangle of 107 mm length and 86 mm breadth. Exit the sketch option and click on the Extrude the newly created feature to 7.5 mm. Let us create threads for the 10 mm hole by clicking on the Thread option. The designation is M10 into 1.25 and must be created on all 4 holes. Now we are going to use the Thread Modeller plugin to create actual thread, and once you have clicked on Thread Modeller option, select all the threads we have created. We are now going to design the base plate and again click on the new sketch to begin the drawing. Change the unit of the length from inches to millimeters. This is not always necessary, but you can do it for your convenience. Now proceed to create a rectangle sketch of 152 mm breadth and 167 mm length. Create a line of 29 mm just like what we did previously to create a drill hole of 10 mm. Use Circle option to create a circle of 10 mm diameter. Use the Line option to create a horizontal and vertical reference line. Use the vertical line to create a mirror of the circle on the left. Click on the 2 circles to create a mirror of the 2 on the bottom using the horizontal line as mirror line. Use the point option and adjust it in such a way that it is 16.5 mm from the top and 57 mm from the right. Use the mirror option to create a mirror of the point onto the left side. Use the mirror option again to create the same points on the bottom using horizontal line. Now go to the point option to create a new point that is 14 mm from the left and 49 mm from top. Now create a mirror of the point below the horizontal line, which can be done by using the horizontal reference line as the mirror line. Select the present 2 points to create a mirror of them on the right side using the vertical reference line as the mirror line. Now create a circle of diameter 16 mm and copy each of the circle to the points we have created. Use the center point of the circle as the base point and copy them to the new points. Let us now exit the sketch and use the extrude option to extrude the sketch to 20 mm. Now click on the bottom surface to create sketch to remove a small portion from bottom. Create a concentric circle of radius 20 mm over the 10 mm hole and do it on all the 4 holes. Create them using the mirror option like how it was done previously. Remove about 6.6 mm from the base plate using the extrude option as we are resting the bolts in this area. Now let us create the same thread we made for the top plate too by using the thread option followed by the thread modeler. We do not need the coiling on the hole of diameter 20 mm, so once done let us proceed for the next part. Start by clicking on the sketch option to create a new sketch and select the XZ plane. Use the polygon option to create a hexagon sketch. The length between the 2 edges of the polygon should be 17 mm. Extrude the polygon sketch to 6.6 mm. Now let us create a circle sketch on the top surface of the part. The circle should be tangent to the edge of the polygonal surface. Now click on the extrude option and then select the intersect option. Then go to the taper option in the advanced properties side to set the taper angle to 45 degrees. Repeat the same procedure on the bottom surface of the design. Use the point option to create a point at the center of the design. Then using the hole option, create a hole of diameter 10 mm. Now we are creating thread M10 on the inner surface of the design. Then using the thread modeler option, select the thread created and click OK. Start by clicking on the sketch option to create a new sketch and select the XZ plane. Use the polygon option to create a hexagon sketch. The length between the 2 edges of the polygon should be 17 mm. Extrude the polygon sketch to 6.6 mm. Now let us create a circle sketch on the top surface of the part. The circle should be tangent to the edge of the polygonal surface. Now click on the extrude option and then select the intersect option. Then go to the taper option in the advanced properties side to set the taper angle to 45 degrees. Create a circular sketch of radius 10 mm on the surface of the bolt head. Extrude this circle to 100 mm. Create a fillet of radius 1 mm at the top. Also create a chamfer of length 1 mm at the bottom. Now click on the 98 mm tall surface to create a M10 thread. Then using the thread modeler option, select the thread created and click OK. Start by clicking on the sketch option to create a new sketch and select the XZ plane. Click on the circle option to create concentric circles of radius 10 mm and 20 mm respectively. Extrude this concentric circular sketch to 60 mm. Next step is to create interior threading. Select the interior surface of design and go to thread option. Select M10 into 1.25 designation. Use thread modeler to create actual thread on inside. Let us proceed to assembly. This is a spare sheet we simply designed which we place in the fixture for milling or drilling purpose. Let's proceed to assembly by opening the parts we have designed. Let us separate parts from our view. We need 2 top plates, 4 M10 bolts and 4 M10 nuts. First step is to click on the constraints option, and once done, select the mate option to select the bottom side of top sheet to get it to the top of the spare sheet. Click apply once the top plate is mated on top of spare sheet. Use flush option to level the top plate to spare sheet. Thus the plate is set on top. Now go to constraints option to use the mate option to select the top edge of the top plate to the bottom edge of the spare sheet. Use flush option to level the top plate to spare sheet. We forgot something, so I am saying this. We need 4 same copies of the hollow cylinder. Click on the constraints option and then select the hollow area of cylinder to match with the hole of the second top plate. Use the flush option to set the hollow cylinder to the bottom surface of second top plate. Another alternative method is to use the insert option and then mate the two using the opposed option as shown in video. Repeat the same procedure for the other 2 hollow cylinders. Now use the same insert option to get the base plate to attach to the hollow cylinders. Now let us assemble the nuts and bolts to the semi-arranged assembly. Use the constraints to arrange the bolt exactly below and adjust it in such a way that the bolt head rests in the area of 20 mm circle, of which 6.6 mm has been removed from below. Do the same for all of the other bolts in such a way that they are arranged as how we have done for the first bolt. Use the constraints option again to attach the nut to the end surface of the bolt as shown in the video. Repeat the same for the other 3 nuts. The bottom surface of the nut has to be attached to the top surface of the top plate. Repeat the same for the other 3 nuts. We are now finally done with the 3D modeling of the design. So let us proceed to the making of this fixture in our college workshop.
Let us now dive into the production venture of the sheet metal fixture. So the first step is to create holes in the top 2 plates as well as the base plate using a standard drilling machine. Create holes in the testing sheet using the same drilling machine. Here is an assembled model of the sheet metal fixture. In order to make it work, we need to remove the top portion from the sheet metal fixture. We have used a chalk to represent this as per shown in the video. Now our next step is to create pockets on top of the sheet metal fixture. This is done with the help of a CNC machine, and while performing the project we have used the supervision of supervisors and faculty from its Planning Dubai campus. Watch carefully on how the CNC machine is being operated so that the pockets can be created on top of the sheet metal fixture carefully with the help of coolant.
Now set our faucet. Right on it. Only Z. G94 space G56. G56. Enter E1. Enter M06. Enter D1. Enter M03. Space S1224. G0. G0 space Z100. Enter and select milling operation. Pocket. Depth you have to change. No, depth from here it will take, no. Depth you have to change.
Minus
Instead of minus 12 is the minus
4.
15 or
You can able to change things.
Using 3D designing softwares like Autodesk Inventor or CATIA can help us generate CNC code which can be entered into our CNC machine. From here we can see how the pocket can be created. Periodic checkings on the CNC machine as well as the progress on the CNC fixture has to be done only by the supervisors and not by the students performing the project. So care must be taken by ourselves. As per the requirements, we have created the pockets on top of the sheet metal fixture. Now our next step is to test the sheet metal fixture to see if it performs as per needed and the requirements are being met by the sheet metal fixture. For this, we shall be performing the function of bending on the sheet metal fixture. Let's see if the sheet metal fixture works as per our requirements. We are performing a circular sheet stamp on the sheet metal with the help of the sheet metal fixture. This is done similarly as how we have created the pockets, but this time we have done a circular sheet stamp definition using CATIA software. Here is our result of the circular sheet stamp on the sheet metal fixture, and we can say that the sheet metal fixture works to its fullest. Thank you for watching our video. Please subscribe to our YouTube channel. Like, share and subscribe to our YouTube channel so that you won't miss any videos that gets uploaded to this channel. Thank you.